Okay, good morning, class. How are you today? Okay, so today we continue on chapter 7, right? Work, energy, and power. Okay, so 7.1 work, energy, and power. So, first of all, okay, what is actually work? Okay, so work is a energy used to move or change an object. So actually another one, the meaning or let's say for they ask you the meaning of the energy. So the energy is the capability to do work. Okay, but what's the meaning of work? Work is the energy used to move or change an object. Okay, so the SI unit for work is joule, or sometimes we can put Newton meter. Okay, and this is the formula for work. Okay, for work is actually the force multiplied with the distance. So W is equals to Fs, right? So what is W? W is a work, F is a force, okay, in Newton, and S is a distance in meter. So mean here you have to know that if you do a work, okay, there must be a distance. So let's say if I push a box, okay, so the box must be move, okay, in a certain distance. Then if we consider we do a work. Okay, so let's say if I push a wall, okay, so if I push a wall, the wall is not moving, right? So when the wall is not moving, so means there is no distance. So when there is no distance means there is no work being done. Okay, so you have to know if you want to do a work, there must be a change of distance there. So let's say from point A to point B. Okay, so let's say you push a box, okay, from point A to point B. Okay, so that's we call it as a work. Okay, and the SI unit for work is a joule. Okay, so SI unit is a joule. Okay, the symbol for joule is J. Okay, and or we can put, okay, because work is force times displacement, right? Force multiplied by distance or displacement. So force, the unit of force is Newton, okay, while the unit for displacement is meter. So that's why you can put Newton meter, or more simplify, you can simplify it, just put joule also can, right? So that is work. Okay, what is a kind of energy transfer? Okay, so let's say if you want to push a box, right? So mean of course the first one you have a chemical energy inside of your body. So every food that we eat actually they have the chemical energy. So inside of our body is a chemical energy. So when you push a box, so when the box start moving, okay, so every object that move must have the kinetic energy. So from the chemical energy that we have in our body, so when you push the box, so the box start moving, then it will change to kinetic energy. So that's why it said work is kind of energy transfer. Okay, energy change, okay, from another form to another form. Alright, so work is done if an object atom opened by a force move in the direction of the force. Okay, so let's say if I have a box here, okay, so let's say you push the box in the right there, into the right, okay, so you push the box into the right, so means the object also will move to the right also. So that means that is considered as the work is done, right? Okay, so what is the definition of work? So work is the force multiplied by displacement, or you can say the product of force and displacement in the direction of force. Okay, so what's the meaning of work? So force multiplied by displacement. Okay, force multiplied by displacement, or you can say the product of force and displacement. Okay, so that's the same. Okay, so this is the formula, and remember the unit for work is joule, or you can put Newton meter. Okay, so let's see another thing about work. So the SI unit for work is joule. Okay, is joule. So 1 joule of work done when a force of 1 Newton, okay, is used to move an object over a distance 1 meter in the direction of force, there is 1 joule is equals to 1 Newton meter. Okay, so means if you the work we consider that we done 1 joule of work, okay, if you use 1 Newton, okay, of force to push the object, okay, so it can move in 1 meter. Okay, so it consider we do 1 joule of work, okay, if we push the box, okay, the force that we use to push the box is 1 Newton, and also the box will move in 1 meter. So that is called as a 1 joule. So 1 joule is equals to 1 Newton meter. Okay, so that's the meaning. If they said 2 joule means 2 joule of work, right, is done, okay, when a force of 2 Newton is used to move over a distance in 2 meter in the direction of force. Okay, so that's the meaning of joule. So use units of Newton meter is used to measure the moment of force and energy. Okay, so which are two physical, okay, which are two physical quantity that are other than work. Okay. So kilojoule, okay, and megajoule are larger units used in the measurement of work. So kilojoule is 10 power of 3, right? And mega is 10 power of 6. So let's say if I have a 3 kilojoule, so means 3 times 10 power of 3 joule. Okay. If I said 3 megajoule, okay, M capital letter M, so 3 times 10 power of 6 joule. So this is another measurement of joule if the energy used or if the work done is too large. Okay, so this is another measurement that we can use. Okay, if you can change to prefix, okay, not only kilo, mega, okay, can also be like, let's say kilo after kilo is kilo, mega, deca, right? So all that is the prefix, the one that you learn in form 1. Okay, you can describe giga, right? Giga 10 power of 9, right? So that one is also can be used. Okay, if let's say you calculate there are too many, let's say 3 giga is 10 power of 9, right? So 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8, 9. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. So they say this is what the calculation that you get. Okay. So you cannot put like zero, this one too many zero, right? So you can change to prefix 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you refer the prefix table, so you can change here to 3 times 10 power of 9. So this one you change to standard form first. Okay, so 3 times 10 power of 9. Then you know 10 power of 9 is actually giga. So you can put 3 gigajoule like that. Okay, so this is how you change the unit. Okay, if the calculation is too big. So example of the work done. Okay, so the first one, pushing a shopping cart. Okay, of course there will be a distance. Okay, and you have to give a force to the shopping cart. Then the shopping cart will move in a certain distance. So means the work is done. Okay, and also work done by the brake. Okay, when the car stop. Okay, so when you push the brake, okay, so of course there will move in a certain distance first, then it will stop. Okay, so that is also called as a work done. Okay, and also the weight lifting. Okay, so the weight, the slotted weight will be move in a certain direction, right? When you lift it, so means there is also a distance, so it's considered as the work done. Okay, so example of work not done. So the object that is acted upon by force remains stationary. Just now, like I said, example when you push a wall. So when you push a wall, of course the wall will not move. Okay, so mean there is no distance. So when there is no distance, the work is zero. Okay, because work is actually force multiplied by displacement, right? Work is force multiplied by displacement. So when the displacement is zero, okay, so of course the work also will become zero. Okay, and the direction of the motion is the perpendicular to the applied force. Alright, so here the example, the waiter walking towards the dinner. Okay, so the direction of apply force is here, right? Okay, is here. All right, and then also when you leave the when you leave the when you leave the glass also, okay, is you go leave it up, right? So means it's 90 degrees. Okay, so when 90 degrees means the work is not done. Okay, so it must be in the same direction. Just now like weight lifting, right? Okay, you lift up the weight, okay, into the upper direction, okay, and then also the weight also move in the upper direction, so means in the same direction as force. Okay, so the weight move as the same direction than force, then we consider it as a work. But for this one, okay, you lift up the glass, okay, but you move in the to the right, so this one is 90 degrees, so this is not considered as work because the direction of force is not same as the direction of the movement of the object. Okay, so this is the example of the work done. Okay, lifting a box, okay, from the floor, climbing a flight of stairs, okay, compressing a spring, rowing a boat, okay, climbing a tree. So if you notice all this, the example of work done, okay, there must be a distance, okay, a change in distance. So example when no work done. Okay, so when you pushing hard on a box which does not move. Okay, so let's say the box is very heavy. Then you try to push it, but the box is not moving. Okay, because it's too heavy. So that is so consider the work is not done. Okay, even you apply so much force to it. Okay, but it's still consider the work is not done. Alright, and then standing still with the load on one shoulder. Okay, so let's say if you lift up your school bag, okay, and then you just stand there, okay, without moving, okay, so that's one also is considered, okay, there is no work done because there is no distance. Okay, and then watching the Olympic on television. So when you watching means you just sit, okay, you just stay there. So also no distance, so no work done. Okay, so pressing a heart against wall. So let's say if you push a wall and the wall is not moving, of course, right? So means there is no work done. Okay, or sitting on a bench. Okay, so basically what we have to know, okay, the work done if there is a change of distance. Okay, there must be a certain distance that the object move, then we consider it as a work. Okay, if not, it just the object is still there, or we just sit, okay, doing nothing, that one is considered as no work is done. Okay, so this is one example, okay, how to calculate work. Okay, so usually usually let's say if you want to calculate a work, right? So let's say example here, I give an example. So let's say the force is 10 Newton. Okay, so you push a box, okay, 10 Newton. Okay, and then the object will move, okay, in certain direction. So let's say the distance is 7 meter. Okay, so then you using this formula, right? So you got 10 times 7. Okay, so your answer should be 70 joule. Okay, so what is the difference between this diagram, okay, and this one? Okay, as you can see here, the force here is actually in the straight line, right? Okay, the force in the straight line. But this one, the force is not in the straight line. Okay, so it inclined. Okay, the force is inclined like that. It's not in the straight line. So when it's not in straight line, you cannot use directly this formula. You cannot use like 10 multiplied by 5. Okay, cannot. Okay, so you have to change. Okay, you have to do some calculation first for the force. Okay, to get, wait for a moment. Adik letak kat situ, Dek. Tak maaf ada kelas. Okay, sorry. Alright, so here the force is 10 Newton and it move in 7 meter. So you just multiply 10 multiplied by 7. Okay, so this one it means the force move in the straight line. But this one the force is not in the straight line, so it has an incline like that. Okay, so you have to do something, okay, to find the force first. Okay, so if you want to find F, so W is equals to Fs. Okay, so for the F, you have to put F cos theta times S. Okay, I'm not sure whether you already learn about trigonometry. Okay, the one cosine tangent. Okay, so if let's say, how do I got cos? Okay, how do I change to cos? Okay, because if you want to use F here, the F must be in the straight line. Okay, it cannot be like this. Okay, so you have to find the straight line for the force in the straight line here. So you have to find F here. Okay, this is the force 10 Newton. Okay, you want to find F here. So we make if you know trigonometry, you must form the right angle triangle, right? Okay, 90 degrees. So you have to form the triangle here. Okay, 90 degrees. So how I want to find the F here? So this one also already been given 40 degrees. Okay, so it's just like I'm drawing a triangle. Okay, so this is 90 degrees. Okay, this is 10 Newton. Okay, so I draw it back. So I want the F here because I said the F must be in the straight line if you want to use this formula. Like this one is already straight line, right? So you just can multiply 10 multiplied by 7, you got 70 joule. Okay, but for this one, the F is not in the straight line. So means you have to find here the F. What is the F here? So you already know this is the adjacent, right? This is adjacent. And 90 degrees, this is called as the hypotenuse. Okay, so I repeat again. Okay, the info that been given here, okay, this is what we want to find. Okay, so F is actually the adjacent. Okay, and the 10 Newton is being given, this one is hypotenuse. Okay, so adjacent and hypotenuse, okay, we use a cos, right? So cos, okay, what is the theta here? Okay, the angle here is 40. Cos 40, okay, this one is adjacent. So adjacent is F, right? So F, okay, divide by the hypotenuse is 10. So if I want to find F, okay, so this one is divide, right? So when you change here, it will become multiply. So 10 cos 40. Yeah. Okay, so 10 cos 40. So 10 cos 40 is, wait for a moment. 10 cos 40, you will get 7.66. Is it? Okay. 7.66. Okay. And then it said it moved in 5 meter, right? So you times by the distance here, 5 meter. So times 5, you will get 38.3. Yes, very good. Okay, 38.3 joule. Okay, so this one I just want to explain how does you get the answer cos theta. Why you use F cos theta? So actually F cos theta is derived from the formula here. Okay, divide change here become multiply. Okay, so you will get F cos theta. Okay, so that is the answer. Okay, so if you want remember, okay, the force must be in the straight line, cannot in the inclined force like that. Okay, if you got like that, you have to change to straight line. Okay, but you just remember the formula. Okay, and you can, if you can understand, maybe you can derive. Okay, but this one I just want to show, okay, how does it get f cos theta. Okay, so this is solution. Okay, so for this one you cannot use fs. This is wrong. Okay, so if you learn physics, the force must be in the straight line. Okay, so cannot you straight away use 10 multiplied by 5. That one only can be used if like this. Okay, you have to change in the straight line first. Okay, find the straight line force, then you use it. Okay, so this is wrong. Okay, don't use this one. Okay, so this one, can you try to calculate? So the force is 10, 20, and the distance is, so use W is equal Fs. This one I think no problem because the direction of the force is in the straight line like that. Okay. Later I will show you proof, okay, why I say F cos theta. That one is wrong. Okay, so if you already have the notes or you see the notes, okay, maybe you have printed, so please do a correction. So what is the answer for this one? The force is what and what is the distance here? Why this one always come up? Oh my. Okay, so this is the formula. Yes, 100. So 20 Newton times 5, right? So 20 times 5, you will get 100 joule. Okay, so let's check whether the answer is correct or not. Yes, 100 joule. Okay, energy. Okay, so just now when we start our class, I already explained what is actually the energy. So energy is the ability, okay, of an object to do work. Okay, so if you have no energy, so mean you cannot do work, right? So energy is the ability of an object to do work. Okay, so the SI unit for the energy is joule. Okay, and when the work is done of an object, okay, so the object regains energy. Okay, so just now like I said, okay, the energy being transferred, right? So inside our body we have a chemical energy. Okay, so when you push the object move now. So now the energy is being transferred. Okay, it's being transferred to the box, and the box can be moved. Okay, so let's say if you have a box, the box is stationary. Okay, and when you try to push the box, okay, so in your body you have a chemical energy. Okay, it comes from the food that we eat. Okay, and then we went to push the box. Okay, so there is a transfer energy. Okay, so the energy that been transferred is from the chemical energy from our body. Okay, and then it changed to, and it transferred to the box, and the box have the kinetic energy. So then the box will be moved. Okay, so 1 joule energy is used when a force of 1 Newton is used to move an object over a distance of 1 meter in the direction of force. Okay, so this one is same like work. Okay. So the next one is the power. So power is the rate of doing work. Okay, so in electricity, just we learn in the previous chapter, right? So P is equals to VI. So that one is for electricity. Okay, P is equals to VI. Okay, but for the work, for power, right? Power for the energy. Okay, so we use P is equals to work divided by time. Okay, and the unit must be in watt. It just seems like the electricity. Okay, watt, or the you can simplify it to W. Okay, and or we can put J as -1. Okay, both also same because work is in joule, right? And the time is second. So J divided by S, you will get J as -1. Okay, so that's the meaning of power. Okay, the rate of doing work. Okay, so this is the formula. Okay, work divided by time. Okay, and the SI unit for power is watt. Okay, so power of 1 watt is used when 1 joule of work is done in 1 second. Okay, so what we can define? So let's say you got the answer 1 watt. So when you got the answer 1 watt means in 1 second, okay, you release a energy or you do a work 1 joule. Okay, for 1 second, 1 joule. Okay, if 2 watt means 2 joule for 2 seconds. Okay, so that's the meaning of watt. Okay, so this is already derived. Okay. Alright, energy and power. Okay, so it says here a student of mass 60 kg runs up a flight of stairs, okay, of height 5 meter in 8 seconds. So calculate the useful power developed by the student. Alright, so for this one, P is equals to W over T. So this is the formula, right? Okay, and then we know here they didn't give you the work, right? You see here in the question, they didn't give you a work. So mean you have to calculate the work first. Okay, so we already learned just now, work is force multiplied by displacement. Okay, but you know the force is in the Newton unit, right? There is no force also given here. So how you want to find force? Okay, here the force is actually based on the mass of the student. Okay, so you have to change the mass to weight. Okay, so how to change? W is equals to mg. Okay, this is the formula for weight. Okay, W is equals to mg. Okay, so I repeat again. So this one, this is the formula that you need to use. Okay, power is equals to work divided by time. Okay, here there is no work given. So means you have to find work first. Okay, and we already learned, okay, the formula for work is F divided by F multiplied by S or displacement, right? So force multiplied by displacement. But there is no force given here. Okay, like 200 Newton, no. They didn't give you any force. So where the force come from? So the force come from the mass of the student. But the mass of the student here, you can see the unit is in kg. Okay, but for the force is actually the unit must be in Newton. So I mean you have to change the kg to Newton. Okay, so how to change the mass to weight? Okay, so you just multiply by 10. Okay, so mass is 60. Okay, so G is actually the gravitational acceleration. Okay, so there is 10. Okay, so 60 times 10 you will get 600 Newton. Okay, so remember weight is Newton, mass is kg. Weight and mass is a different thing. Okay, mass is not depend on the gravitational force. So let's say if you go to the moon, okay, if you at earth, okay, your mass is let's say I give example 70 kg. So let's say if you go to the moon, your mass is still 70 kg. Okay, but your weight is different. Okay, but your weight is different between the earth and the moon because the earth and the moon have different gravitational force. Okay, let's say in the earth there is a 10, right? Your gravitational force is 10, but in the moon is 1/6 from earth. So means 1 times 6, I think 10 divide by 6 is, wait for a moment, 10 divided by 6 is around 1.67. Okay, so means the gravitational force is in earth is 10, the gravitational force in moon is 1.67. So means your weight will be different. Okay, so mean it much your weight much higher in the earth than the moon because of the difference in the gravitational acceleration. Okay, so here Fs, so F is we already calculate here 600 Newton. Okay, and the S is the distance here is 5. Okay, so you will get 3000 joule. Okay, then after that you can put in the formula. Okay, 3000 divide by 8. Okay, so 3000 you divide by 8, you will get 375 watt. Right? So I explain again. So this is the formula, work divided by time. We don't have work here, okay, but means we have to find first by using this formula, okay, Fs. You already know F must be in Newton, right? So there is no force given here, okay, but you can use the mass here to change it to force, okay. So how you want to use change it to force, okay, so you use this formula mg. So m is the mass 60, okay, and the gravity is 10, okay. So it already give you 1 kg 10 newton. So means 60 kg, so 60 times 10, right? So this is actually based from this formula. Okay, so m is 60, g is 10, so you will get 600 newton. Okay, so the F is 600 Newton. Okay, and then what is the distance is 5, so you will get 3000. So now you already F has a W here, so you can put in the formula 3000 divided by time here is 8 seconds. So when you divide, you will get 375 watt. So that is the power. Okay, that is the calculation. Okay, try to answer for this. Can you try to answer for this one? I don't know why. Keep. Okay, can you get the answer for this one? So remember, this one is 100 kg, right? Okay, so you can have to calculate the work first. W is equals to Fs. Okay, so the force here is, you have to change here first, right, to Newton. So 100 times 10. Okay, so this one is actually based from this formula. Okay, you need to change the kg to Newton first. So 100 times 10, okay, so you will get 1000, right? Okay, and the distance here is 2. Okay, so you will get 2000. Okay, then you can use the formula 2000. Okay, and what is the time? Divide by 10 should be 200 watt. Okay, very good. Yes, so the answer is 200 watt. Okay, so that's how you use the formula. First, force multiplied by displacement. So remember, the force must be in the Newton. So if we give you mass, all right, so you have to change the mass first, the kg to Newton, by multiply it by 10. Okay, and then you substitute in the work formula. So you already got work. Then you put in the power formula here. Okay, so that way we get 200. So let's say let's check whether we got the correct one. Yes. Okay, so very good. Okay, so that's how you want to find work, okay, and also power. Okay, so for the energy, there are many types of energy. So after this, we will learn about the potential elastic energy, gravitational potential energy. Okay, so there are two types of energy there. Okay, that we will learn 7.2, I think. Okay, 7.3, we learn about the principal conservation of energy. So if you see in the Google Classroom, I already assigned for you a quiz, okay, based on what we learned today. Okay, so can you try to answer the quiz? Okay, so for tomorrow for tutorial, okay, remember please prepare for the tutorial 6.3 and 6.4. Okay, the question that I give. Then we will discuss for the quizzes that you answer, I think 2 days ago, right? So we discuss that one on tomorrow class. Okay, so I see you tomorrow. Okay, so take care class. So please answer the question in the Google Classroom. Okay, so see you tomorrow. Have a good day. Take care. Okay, stay safe. Okay, bye. Welcome.